Hello, all. Welcome to my TBP engineering report. For the first part, for the ultimate goal, it has three. First is using incorrect weights and dimensions ensure proper adhesion windshield to the vehicle. And using incorrect weights and dimensions ensure using is out of sight so pleasing vehicle appearance provided. And the cost and the waste. Using incorrect weights and the dimensions ensure using and the waste costs are kept to a minimum. The current situation is an increase in endopods by team members and the persist and excessive model from using adhesive bid with problems in Plan 2. Over the past 7 months period, the idle situation, the persist specifications for uracil weight are 0.9 to 1 kilogram per car for the Venza and 0.7 to 0.8 for the Camry and Avalon. Proper bit shape forms are isosceles string with nominal dimension seed and 8 millimeters wide and the base by 12 millimeter height. Here is the process of First is the cavity with body primer, cleaned windshield for the fusel sealing, apply glass primer, dry and check, and apply a bit of uracil. Last is installing windshield. The target setting is the width of the piece should meet 5 millimeters to 11 millimeter wide. So here is a fishbone diagram. There's 4 root cause aspects. First is man. The root cause is the robot cleaning procedure is not clear, and new employee knows not cleaned, incomplete training. And for the method, the root cause is too large tip cleaning tools used, and the pump pressure is too high, incorrect temperature, inadequate cure time. Material. For the material, the root cause is incorrect viscosity, shelf life exceeded, excessive waste, and excessive using. For the machine, the root cause is unstable pump pressure, doesn't wear, pump wear, and unstable robot speed. These 4 root causes bad cause speed-wise change together. Here is the 5 whys. The first question is why is the pump pressure unstable? It's because dispense tip too wide or clogged, and the viscosity of uracil is too low or too high. Second question is why did the employee training fail to achieve the expected results? It's because the purpose of training is not clear and there are no strict training standards. The third question is why is the temperature unstable? It's because the environment temperature changes and the cooling equipment failure. Why is the speed of robot unstable? It's because the robot cleaning procedure is not clear procedure, and the robot speed is not adjusted. Why does the size of the tip not meet the standard? It's because the too large tip cleaning tool used and the opening widths won't pop and too high settings. Here is the FNIT diagram. I created into 3 sections. The first section is trainee and employee. We should provide professional training for employees with training outline and practice, and training must have tests and produce staff operating guidelines. For in equipment section, I think perform regular maintenance on the equipment is needed, and equipped with temperature monitoring equipment and equipped with viscosity of uracil monitoring equipment. For the process, I think strictly control the production process and monitoring the data at all times and adjust according to the error. For the FMEZ is corrected by the same steps. For the first step, it has it could be not cleaned up. the effect is affect the subsequent glass coating steps, and the cause can be clean up procedure are not clear. So how to control it? We can control it through object training and instructions. The second is the filter precision. The machine failure can be the potential failure model, and the effect is the glass to go or not go directly to the next station. We can control it by set daily maintenance and standards. The third is glass received glass primer by the robot arm. There's two failure models. The first is body arm failure. The effect can be the glass didn't receive the glass primer. The cause can be data seeding problems or no daily maintenance. How to control it? Mechanical parameter setting and instructions and maintenance training. The second is wrong glass position. Effect is glass primer spray failure. The cause can be misplacement of employees. We can control it by operator training and instructions. Recommend action is set glass position mark. Set right, set correct glass position mark. And for the dry and check step, it only have one failure mode, dry and check failure. The effect can be the coating didn't dry. The potential cause is data seeding problems and machine failure. How to control it? We can control it by mechanical parameter setting instructions and maintenance training. Recommended actions is parameter setting check and their maintenance. Last two steps is glass receive bit of urethane by robot arm. It have two potential failure mode. Bit wise is too wide or too narrow. Effect can be windshield replacement network or clean remove urethane. Cause can be robot speed, dispense type too wide or clogged, viscosity urethane, pump pressure. We can control it by operator training and instructions, mechanical parameter setting instructions, and maintenance training. And also we can buy new equipment, like we can buy new pump. And the recommended actions is parameter setting check, daily maintenance, and new equipment. For the robot arm failure, the effect can be the glass didn't receive the bit of urethane. And the cause can be data seeding problems or no daily maintenance. Control method is mechanical parameter setting instructions and maintenance training. Recommended actions, parameter setting check, and daily maintenance. For the last step, lift and place windshield into body cavity. There are also two failure modes. First is wrong glass position. It can cause broken glasses, and the reason can be the employee error. We can control it by operator training and instructions, and also recommended actions is set correct glass position mark. The second is machine failure. It can cause installation failed. The reason is data seeding problems or no daily maintenance, and we can control it by mechanical parameter setting instructions and maintenance training. The recommended action is parameter setting check and daily maintenance. So this is plan to camera urethane usage. We can see unmanned, the camera urethane usage is highest. This is model production. from different plant. The blue is plant 1, the red is plant 2. This is UNC adhesive usage. The blue is plant 1 Camry. Orange is plant 1 Island, and the gray is plant 2 Camry, and the yellow is plant 2 Venza. This is the uracil adhesive solid waste. Blue is plant 1 Camry, orange is plant 2 Avalon, and the gray is the plant 2 Camry. Yellow is plant 2 Venza. We can see on map the plant 2 Camry has the highest waste, and on July, plant 1 Avalon have the lowest waste. Here is the control charts. Here's the control charts and the expert chart of units. For the lean management, 7 waste. I discussed 7 waste and Kaizen. For the 7 waste identification and elimination are the basis of continuous improvement. The goal of implementing these 7 types of waste is to identify and eliminate all levels of waste during the manufacturing and assembly process. In order to eliminate waste, it is important to understand exactly what waste is and where it exists. Develop strategies for each type of waste to reduce or eliminate its impact, thereby improving the overall performance of the organizations. So, how automobile industry apply Kaizen? The company apply Kaizen methodologies into reduce cycle time and non-value added activities, production line balance and standard work implementation, eliminate rework and quality issues, inventory optimization, and reduce machine failure, staff skill improvement, value engineering implementation. This is countermeasures and conclusions. On January, the process is in control, and on February, the temperature is below freezing. The countermeasures is the heating device maintenance, the temperature and 75 degrees, and new employee assigned to the USC robot area. The countermeasure is incomplete robot cleaning procedure training. And the USC bid application speed was recorded to be 340 millimeters per second on average, and the pump pressure was recorded running 7.5 on average, and unmatched. The temperature rose back to rose back to 75 degree, and the temperature on plant 2 rose to 83 degree. The pump pressure is reduced to 7.5, and the robot speed increased to 365. The using application tip head about glass was averaging 10.5. On April, the temperature rose to 100 degree, and the temperature of the plant 2 rose to 19.2 degree due to a failure of cooling equipment. the pump pressure rises to 4.9, and the robot speed drops to 360 millimeters per second. And the urethane application tip height above the glass was averaging 10.2 millimeters. And on May and on June, complete the design of the dispensing head, tightening the control of the tip opening, and install new heating and cooling equipment to control the temperature. Increase the height of the tip above the glass check piece, and install the measuring device, and also install a robot TV to control the speed of robot. And on July, every process is in control. So in the future, I think I will improve the staff training syllabus and instructions and develop complete training content. And also I will develop strict machine maintenance instructions and set up a daily checklist for machine error. And I also will target employment of employees who can edit robot parameters. So this is my presentation, and thank you.